so that we had that huge amount of memory issue. I guess it was like 700 megabytes, I don't recall, but it was a huge amount, which is something that we don't want. So what you need to do is to first wait for this internal buffer to get emptied and then do another write. Now this process that the stream does to empty this buffer is called draining. And we have to keep an eye out on this event, and it's actually an event. So you say a writable stream dot on drain, and then you do your code. We're going to see all that in code, but I just want to say that you have to wait for this internal buffer to get emptied, and after it's completely empty, you are now safe to push more data into this internal buffer, or I should say write. So this is how a writable stream works in Node. It's just an object that has some events, properties, and methods, and also this internal buffer. Let's now take a look at the readable stream object. Let's see how this works. So again, we have our readable stream object, and we can get this by running something like fs.createReadStream. And what we're going to end up with is this object. Now, just like a writable stream, we have an internal buffer, size of which is at high watermark value, which is by default 16,384 bytes, or just 16 kilobytes. Now, again, just like a writable stream, we have some events, properties, and methods available on this readable stream. The way that we can push data into this readable stream is by calling stream.push and then some amount of data. So we keep pushing into this internal buffer, and what's going to happen is that once it's filled, we're going to get an event. And the event is called stream.onData. So the event's name is data. So you need to run this code on your readable stream and keep looking for these data events. So once the internal buffer is full, we're going to get an event called data, and we're going to get this data all in one chunk here in this callback function. So we're going to pull the data out, and we're going to do whatever we want with it in this 3 dots section. Maybe you want to write it to another writable stream, or you just want to read it. It's up to you. So this is a readable stream, and you use this readable stream to make huge data, a huge message, into different chunks. So let's go back into our previous example. Here, let's say that you have this 800 megabytes of data. Let's say it's a message coming to your network card. Maybe it's a request, or if it's a file you want to read. So what should you do in this case? What do you think? Let's say that I want to write a data to a writable stream, excuse me. Maybe it's a file, and this data is so huge. What should I do in that case? Well, what you should do is to first create a readable stream off of this data, be it a file or a request, anything. You first create a readable stream, and then when you create a readable stream, you're going to get the data in chunks of this size, this 16 kilobytes of size. So you get the data, and then you write to this writable stream. So this is what you should do if you have a huge amount of data and you want to write it somewhere. First create a readable stream, and then you write it. Right, so this is really how this writable stream and readable stream work. Now, what about duplex and transform? Now, they're just like these two. A duplex is just a stream that you could both write to and read from. So a writable stream and a readable stream, they only have one internal buffer, only one. But a duplex has two. A transform has two, one for reading and one for writing. So these are all the streams we have in a nutshell. Now let's jump right into our code editor and try to use these streams, and let's see some interesting results. Let's first fix our problem with that memory issue. Alright, let's try to work ourselves through this problem by some of the basic things that we know. So first of all, I'm going to copy paste this code because we're going to have a new solution to this write many problem, and I'm just going to comment this portion of the code out. I'm also going to copy this include line. It's going to be the same, but still. Alright, so this is our stream object, that blue rectangle we talked about in the slides. So let's try to see what is happening here, and let's see how we can fix this memory issue problem. Now you might be thinking, is it possible to get the internal buffer of this stream? Well, it's not really recommended and it's not really documented in the Node.js documentation, so we're not going to do that. Instead, what we're going to do is to use two properties that we have available on the stream object that will indicate how much of that internal buffer is filled. So I'm going to comment the for loop out, and I'm going to just log these two properties. The first one is stream.writable high watermark value, actually writable high watermark, and this is the size of our internal buffer, which is by default 16 kilobytes. So if I run this code, I want to get that value that we talked about in the slides, 16,384 bytes. Now, it is possible to change that value, but you don't really need to do that in a lot of cases unless you are implementing your own streams, which is something that we're going to get into a little bit later in the video. Alright, so let's try to log another value, which is stream.writable length. Now, this value indicates how much of this buffer is filled. So if I log it, I should get 0 because I haven't called stream.write until this point. So let's try to write and then get that value again. So I'm going to say stream.write. Let's just write this. Okay, really simple. And let's log this writable length after this string. And actually, you know what? I'm not going to write a string to our stream because you are not limited to just writing strings to streams. You could write anything, any zeros and ones. You could write an image, a video file, anything. So what I want to do is to just first create a buffer out of the string and then write it. In that case, I think it will be easier for you to understand what's happening. So I'm going to create a buffer first, and I'm going to say buffer.from this, or actually just string. And then I'm going to write this buffer to my stream object. Now let's run this code. Alright, so this log, that is 0, we haven't wrote anything yet. But after we wrote this buffer to our stream, now our writable length is 6. And if you're wondering to know why is it 6, it's not because it's 6 characters. Well, actually yes, but it's more like that each character is represented using only 1 byte. So if I just log the buffer, so log buff, you can see that I have a buffer that has 1, 2, 3, 4, 5, 6. So this buffer's length is 6 bytes. I write this buffer to my stream, to that internal buffer, and now this writable length is 6. If I try to write some more things to this buffer, if I try to write the same thing but multiple times, if I save and run it again, now the writable length is 30. So what's happening at this point is that we're just pushing these buffers to that internal buffer, to this stream object. So we are gathering data, right? So you can imagine what's happening inside of this loop. We keep writing to this buffer and we keep increasing this writable length value. But the important part here is what happens when this writable length gets the same size as the writable high watermark value. So this is going to be 16 kilobyte. What will happen at that point? So what we need to do is to check and see what this write method returns. If it returns true, it means that we are safe to write more to our stream. It means that our internal buffer is not full yet. But if it does return false, it means that our internal buffer is now full and we should now wait for the stream to empty that data and do the final write, which is to write to our underlying resource, which in this case is just a file. So what I'm going to do right now is to, let me first zoom in a little bit and also comment out all the logs that I have. So I'm going to comment this for loop again and also this time end, and I'm going to remove all these writes. I'm also going to remove our writable length at this point because we know that it's 0. I'm going to keep the high watermark value to remind ourselves what this value is. And what I'm going to do right now is to create a buffer that has the same size as this high watermark value. So the way I can do that is to just say buffer.alloc and then specify size. Whatever size I specify here in bytes, now my buffer will have that exact same size. So this is how we allocate a buffer, how we create a buffer. This is one way of doing it. And you could also here specify an optional parameter which specifies how to fill this buffer. So if I just say character A, it means that fill all of my buffer with this character. Or you could specify a number or another buffer or actually nothing. So let's just do a quick recap on buffers. Let's create a buffer that has a size of 100 megabytes and fill it with this character A, or actually just a number. Let's just say a number, maybe 1 or 10 actually. And I'm going to specify 100 megabytes. Now, if you want to convert between megabytes and bytes or kilobytes to bytes or whatever, just do a quick search on Google and that will pop up. So just say MB to bytes, for example. And here we get this converter on Google. So if I want to create a buffer that has a size of 100 megabytes, just say 100 here, and then I get that number in bytes. Now, if you're not familiar with this notation, this is how we specify big numbers in computers. It means 1 times 10 to the power of 8. So you could either specify this in your buffer to get 100 megabytes, or you could just specify it with those zeros. So you have to specify 8 zeros. 1, 2, 3, 1, 2, 3, 1, 2. Now I create a buffer and fill each byte with 10. Let's select this buffer and see how much memory usage we have. Now, if I log it, you're going to see that we get these numbers. And I'm just going to write these here at the top in case you were confused. So 8 bits is 1 byte. And each bit is either a 1 or a 0. Now 1000 bytes is 1 kilobyte. And 1000 kilobytes is 1 megabyte. Alright, so if you want to create a buffer with the size of 100 megabytes, you have to work yourself through this chart. So 100 megabytes means 10 to the power of 2 times 10 to the power of 3 times 10 to the power of 3, which will be 10 to the power of 8. So 10 to the power of 8. And then you're going to get 100 megabytes. Or you could just use this converter here and convert between these values back and forth. All right. And one more point. In this buffer, when you log it, you're going to get these numbers in hexadecimal. And each hexadecimal value equals to 4 bits. So if I have this hexadecimal value of, let's say 1A, each number corresponds to 4 bits. So 1, 2, 3, 4, 1, 2, 3, 4. Now this is not the exact value. If you want to get the exact value, you could use a calculator or do it by hand, if you will. And you have to switch to a programmer calculator and just put 1A, and the value is 0001, 3 zeros and 1, and then 1010. Alright, so this is our buffer. Its size is 100 megabytes, and it's filled with this value, with 10. So 0A is 10. If you just put A and then switch to digits, you're going to get 10. So 8A in hexadecimal is equivalent to 10 in decimal format. Anyway, so let's create our buffer and take a look at our memory usage. We're logging it, and let me just put in a set interval function here at the end so that our process does not exit right after it's done. So now I'm going to run the application, and I want to take a look at the activity monitor, and sure enough, if you take a look at the memory usage, it's 100 megabytes. Around 12 megabytes is for the whole application, and this buffer is allocating 100 megabytes. And you notice that the memory usage jumped back to 16 megabytes, and it's just this garbage collector thing that Node.js does behind the scenes. Because we're not using this buffer anymore, Node.js will delete that. But if I run it one more time, you're going to see that the memory usage is now 100 megabytes. So whenever you're creating a buffer, you're allocating some amount of your memory to that buffer. We have a warning here. Well, it says that we need to close the file, and it's actually right. We're creating the file here, but we're not closing it at the end, which is bad practice. So I'm just going to close the file here at the end once we're done. So file handle.close. All right, let's now create a buffer of that size of high watermark value and then write that to our stream. So I'm just going to specify this value, which is, should have it in our logs, which is 16,000 something. So I'm just going to paste it here. So I have created a buffer with this size. And now let's go ahead and write this buffer to our stream. So I'm just going to say stream.write buffer. And what will happen at this point is that because our internal buffer is now full, because we're creating this buffer that has the same size as that internal buffer, this function now will return false. So if I just log it, say console.log this, I think we still got that warning, but we're going to troubleshoot that later. So let's run it again, and now you can see that this value, this method returns false. If I try to create a buffer that has even 1 byte less than this value, so I change 4 to 3, now if I run it, this function now returns true. So the important point here is that we need to check every time this function returns false, we need to wait for it to get emptied. Otherwise, if we keep pushing to it, we are buffering that data, and what will happen is that we're going to get some back pressuring. So it's something that we're going to talk about. It's actually this thing that we're talking about right here. In our for loop, if you take a look, we'll keep writing to this buffer, to this stream, this buffer. So we keep writing this buffer to our stream even though we reach this high watermark value. And we're not letting the stream to empty itself. So we're having some back pressuring here, and we're not handling it quite well. We're putting a huge amount of pressure on this stream, on that internal buffer inside of this stream. So how could we let the stream empty itself? Now what we can do is to just listen for an event called a drain. And whenever this event happens, I can't type, right? Whenever this event happens, it means that the buffer is now emptied, that internal buffer is now emptied, and now we're safe to write more to that stream if we want. So let's say that we write this to our stream, and then let's write one more thing to our stream. And in this case, I'm gonna allocate a buffer that has a size of 1 byte. So now we get to this high watermark value. I'm just gonna fill it in this case with just character A, and let's write this one. So this first write call should return true, but the second one should return false, because now we reach this value, this high watermark value. So if I run it, I'll get a true and then a false. But because it's now false, the stream will now take some time to empty itself, and once it's done, it's going to emit this drain event. So if I just log something, we are now safe to write more. If we run it, we're gonna get, actually we haven't got that log. Actually, we're not getting this log because we are closing our file right after this code. So we reach this point and then we quickly close it, and that's it. We're not getting to this point. And when we close this file handle, we are actually also closing our stream. So let's comment this line again, and we're gonna get back to this close, afterwards, because we have to talk about some of the other events like finish and so forth. But let's now focus on this drain event. Now, if I run this again, now I'll get that log that says we are now safe to write more. So our first write returns true, second one returns false, because at this point we completely fill that internal buffer, but now the stream will emit this drain event. If I don't do this, if I don't completely fill my internal buffer, and if I run this, I'm not going to get that log because, well, at this point my internal buffer is not full, so we don't need to wait for the drain event. So you should always wait for this drain event. If you don't, and if you just keep writing to that internal buffer, and if I log the stream.writeLength, writable length, this value should never exceed this value. So this is our high watermark value, and this is our writable length value. And as you can see, this is bigger than this one. You should never let this happen. Whenever this one returns false, you should immediately stop writing to it and instead wait for this drain event. Otherwise, you're going to buffer this data. And we saw what happens when we keep buffering something. If you just buffer something, if you just create a buffer, you're just immediately going to allocate some amount of memory. So you should never let this value get higher than this value. That is a bad practice. That's an awful practice. And you're going to have some memory issues, some performance issues, so do not ever let this happen. Always check for this value, and always, most importantly, check for what this stream.write method returns. If it returns false, you should just stop writing to it anymore. Wait for this drain event to happen, and once the event drain happens, it means that now you could move on ahead and write more to that stream. So if I just, at this point, write a couple more things to my stream, so I just write 1 byte to that stream, and if I just log this writable length value again, now what I'm going to see is I want to get 1 because now we emptied our buffer. So writable length, which indicates how much of our buffer is full, is now 1, because at this point we have completely emptied the buffer. We have wrote to this test.txt file, and now we could just move on ahead and write more to it. And we don't see anything here because this number, it doesn't mean that we're writing 10. If it was a character, it would mean the same thing. If this is confusing, you gotta learn more about buffers. Watch my video about buffers, but just to make it easier for you to understand, I'm going to change it to just an A. I have to scroll all the way down to get those A's, and these A's are these ones. But if I just change 10 to A, save, run a code, and open this up, I'm going to see a whole bunch of A's. Alright, so let's recap. This drain event happens when our internal buffer is full and when it's emptied. Alright? So if we do something silly, if we try to allocate a buffer, if we try to write to the stream a value that has the exact same size, we're going to get into some issues. Because in this case, we're writing again to our stream, but we're making it full again. So this code will eventually lead to the stream object to emit this drain event again, and then we're going to get into this callback, and it keeps happening in a loop. So if I run this, we're going to get a whole bunch of logs because this code keeps happening over and over again. The stream waits for that internal buffer to be completely emptied, and once it's done with that, it's going to emit this drain event. We're catching this drain event here and stream it on drain, and then whenever it happens, we're executing this callback. But in the callback, we're writing again to that stream. So this code will again emit another drain event, and this callback function will keep happening and happening over and over. So with this knowledge in place, now that you understand how draining works, and that you should never write to a stream once it's full, and you could find it out when stream.write returns false, let's now go back to our loop and fix our problem. So I'm just going to first remove all these codes. Or actually, I'm just going to keep them for your reference later on. And let's now work in the for loop. So I'm going to uncomment the for loop out. And let's see what we can do here. So what we need to do is to check for this value. If it returns false, it means that we need to stop the loop. And then listen for the drain event. And then after the drain event happens in the callback function, we need to do something to continue on with this loop. So if you want, pause the video right now and give it a shot. It's now all about your JavaScript and programming skills. You need to stop the loop and then resume it if it's true. Actually, you need to resume it in that drain event. But anyway, you get the idea. See if you can do it. And if you can't, it's fine. I'm going to show you my solution in just a minute. All right. So what I'm going to do first is to, well, if we want to check for this value, so we need to have an if statement. And if this if statement is false, actually if this expression here returns false, so what we need to do is to just break out of this loop and then in that drain event do some stuff and somehow resume this loop again. So the way we can do it is to move this code inside of a function and also move this I outside of the scope of that function. So in that case, in the drain event, we could just call that function, and because we have our I value outside of the scope of that function, we could resume the loop. So we could create a new function here called write_many, and hopefully I'm not defining any other things with this variable. Well, nope, we're good. So this function will have this for loop inside of it. And we also need to define our I variable here outside of the scope of this function. So let I equal 0 and I less than 1,000,000 I++. And you know what, because we are defining this I variable outside, we could just change this for loop to a while loop. The logic will not be different at all. It's just instead of a for loop, it's now a while loop. And now what we need to do is to increment our I value here after we do a write. All right. And also I'm going to call this function right after it's defined. So write_many, and now we're good. Now this code is just like before. Nothing is really different. The only two things that are different is that we now have our I variable here outside of this function. And we also have this function, which we're calling right after it's defined. Now in this case, what we can do is to just break out of this while loop if this returns false, and then in the drain listener, which we're going to define right here after this write_many, we could just call this function again. And what's going to happen is that we already have our I variable at that number that it was previously, so we'll just continue with the loop rather than just starting from scratch and start from I0 and then go all the way up. So let's now define our drain events. So I want to say stream.onDrain. So notice when we get to this point, it means that our internal buffer in the stream is now full. So we need to stop writing, and here we need to wait for the internal buffer to get emptied. So by the time that we get to the callback and we are executing the callback, we are now sure that our internal buffer is now empty. So what we can do is to just call that write_many function again, like so. And now we need to do our if statement check. So if stream.write_buff, if this returns false, so now if this expression returns false, we're just going to break, and that's it. Or because it's one line, I could just remove these curly brackets and do it in one line. So this should now be our solution, and it should work pretty okay. So let's now run our code and see if it works. So I'm just going to delete this text.txt file, and now I'm going to run this code. So node write_many, And now we have our test file, which starts from 0 and goes all the way up to 6 nines here. So our code is working pretty okay. And if we take a look at our memory usage, let's try to run it a couple times. It's pretty fast, so we can't get the process. Well, we did for a couple of seconds, but the memory usage is around maybe 50 megabytes, right? So it's not 200, something that we saw previously. It's definitely not 200 because now we're doing a drain, but in our previous example here, memory usage was 200 megabytes. It was really awful. You should never do this. So we managed to reduce this number down maybe by 4 times, and let's also benchmark the code and see how long it takes. Notice we can't do this right here, because if we do, it's going to run sooner than some of these callback functions. So a good place that we can run this time end function is when our stream is done. So when we're done writing to this file, we want to emit an event and say that, all right, we're done writing, that's it. This is going to be our last callback function that we're going to write, and there it will be a good place to both call the time end function and also close our file handle. So the way we can do that is to check for this I variable and see if it's equal to the last number, which is going to be 6 nines. We're just going to end the stream. So let's do that here. So I'm going to say if I is equal to, and notice we can't just say I equals to 1 million, because we're not ever going to get to this point, because if I becomes 1 million, we're just going to break out of the loop. What we can do is to just say this variable, but -1. So 6 nines. So if you subtract 1 out of 1 million, you're going to get this variable. So if we're in our last write, let me just put a comment here. This is our last write. And I'm also going to say if stream.write returns false, stop the loop. Okay. And for this one, I'm going to write resume our loop once our internal buffer is, once our stream's internal buffer is empty. All right. So now let's do our last write, which is going to be stream.end. This is another method that we have available on the stream object. So using write, you could just write, but when you call the end method, you're going to indicate that this is going to be my last write. So you could also specify a chunk, which I'm going to. So I'm going to specify that buffer, and this is pretty much it. Now, if we run this method on a stream, it means that we're done. If we try to write any more to that stream, like this, this is going to return an error. So when you run the end method, it means that you're done with the stream and you should no longer write any more to that stream. Now, this end method is also going to emit a finish event, which is something really useful that we can sometimes use. For example, in this case, we could, in that finish event, we could run our time end function and also close our file handle. So let's listen for that event. So stream.on finish. Then here, we're going to move our time end function and also close the file handle. All right, now let's try this code and see how long it takes to run. So I'm gonna run the code, and well, looks like we have an error. Let's see what the error is. Right after end. Well, yeah, it's because we need to return this, because if its I is this, then we are calling this, and then we're moving to this right. So we are getting this error that says you should not write after ends, which is something that we just talked about, right? So just return, and that's it. I think this should be pretty much it. Let's run it again. And yeah, it's right. So this function now takes around 300 milliseconds to run, which is the same number, I guess. Yeah, it's slightly the same thing. Maybe this one is a little bit faster, but we can't really say that much faster. It's just by maybe 2% or something like that. So not something that we really need to care about. Now, this code might be slightly slower, but notice that it's because our memory usage is not that big. So if you try to, maybe instead of a million, try to write 100 millions, or maybe a billion, I'm sure that this execution time is going to be slower than this one, because then you are having a huge memory issue. But also the most important point here is that our memory usage is now 200 megabytes, but here in this solution it's roughly around 50 megabytes. And this is going to be more significant if you increase this I variable. So you could now use maybe a billion, 10 billion, and you're still going to get a pretty good memory usage, somewhere around maybe 50 megabytes or 100 megabytes, really something really much lower than our previous code. Now, let's see how many times we are draining. So I'm just going to add a log here and say draining. And let's count and see how many drains we get. What do you think the value will be? So let's run the code. And we're getting a lot of logs if I scroll all the way up. So let's try to count them, and the way we can do that is to just, one way we can do it is to just select all these text and do a copy and then paste it in our code editor. And now here you could take a look at the line number, which is 481. So it means that we drained our internal buffer, our stream, 400 times. Do you think this number makes sense? Well, the answer is yes. And you can get this number by doing a little bit of math. So let's get the file size of our test and see how many bytes we wrote to it. So it's 7 megabytes, but we don't care about that. We want the exact size. So I'm going to right click on it and click on get info. And right here, you can see exactly how many bytes this file has, or this file size, but in bytes. So I'm going to copy this number, and I'm going to open up my calculator, and I'm going to switch to basic mode. So view basic, and I'm going to paste that number in. So this is exactly how many bytes we wrote to this test file, right? Now, if we divide this number by that high watermark value, by the size of the internal buffer, we should get to this number, 481. So let's get that value. I don't remember. Okay, here we have it in our terminal. So it's 16,300 and something. So I'm just going to copy this and paste it in my calculator. And now I'm going to hit the equal sign to see the result of this division. And sure enough, it's 481. Notice that we also have a remainder, which is expected. So in our last write, we are writing something to our file, but that chunk that we're writing is smaller than the size of the internal buffer. So we're not doing another drain. So we are writing 482 times, but we are draining 481 times. Because in the last time, we don't need to drain because the value is less than the internal buffer. And you know what? This could be kind of confusing because we're logging draining, but when we get to this point, we are done draining. So it should be drained, right? Because we're doing draining before this event happens. So right before this event happens, the buffer is getting emptied. But once this event happens and we get to this callback function, at this point, we are done draining. So now we have our internal buffer completely emptied. So it should be drained, and then we could just do our writes again. If we try to log stream.writable length, here we should get 0. So if we just try to do it right here, it should be 0. But right before this event, it should be 16,000 something, size of that internal buffer. Or also it could be slightly higher than that, because maybe our last write that will fill the internal buffer could have a value that's slightly bigger than the amount of space that we have available in that internal buffer. So it could be just slightly bigger, but it's not something that we really care about, because it's just a couple of bytes, nothing really too crazy. Alright, so at this point we are pretty much done with the writable stream in Node, and we covered some of the most important things that you need to know about a writable stream, like the drain event, the end event, write, and that high watermark value. Let's now take a look at the Node.js documentation and try to do a quick recap there. And then we're going to move on to discussing the readable streams. So I'm going to open up my browser and just search for Node.js, and I'm going to go into the docs. And also notice that now we are using Node.js version 18. When we were starting out, I installed version 16. But now, at this point, Node.js has pushed another version out, version 18. So I also switched to Node version 18, which is something that I recommend you to do as well. Now, if you followed along with the course, you installed NVM. And if you have NVM installed, it's pretty easy to change your Node version. Now that we are on version 18, if you want to install another version, you just say NVM install 18 point whatever. Now, in your case, if you are on version 16 or something, just run this command, nvm install 18.12.1. At this point, this is the latest LTS version, but go to the Node.js docs to see what's the latest version of Node for you. And after you install the latest version, you just run nvm alias default 18 point that version that you just installed, and then your default Node version will change to that one. That's something that I just wanted to point out. If you're on version 16, it's still fine, I guess, but this is how we could change versions, and really it's not that difficult. So in the Node.js documentation, I'm going to open up the section that says stream, and here you could see that we have one API for stream consumers and one API for, if I scroll down, for stream implementers. Right now we're discussing the first one, stream consumers, but later in the video we're going to move on to the second API as well. Alright, so in the API for stream consumers, you notice that the first code that Node.js gives you is an example using the HTTP module. Now I just want to say this right now. In this video we're just going to stick with the FS module, but the concept is just the same thing. So if you understand how to work with streams in the file system module, if you then move to HTTP module or the net module or any other modules in Node that use the stream object, you're not going to have any problem whatsoever using those streams. For example, here, if you take a look, we have requests on data. Now this is something related to a real stream, which is something that we're going to get into in just a minute. But this res object is a writable stream. So if you take a look, we are writing to this response object, and then at the end we are just calling the end method, which you could also specify a chunk to specify that this is going to be the last chunk to write to the response object. Or you could just not specify anything and indicate to say that this response is now done. So the same concept, the same things, they're both inheriting from the same stream module. So if you understand streams using file system, the rest will be easy. Now here's writable streams, and here are examples where in Node this writable stream is being used. One example that we looked at specifically in this video is FS write streams, but it's also used in the HTTP module, Zlib, Crypto, TCP sockets, and the child processes standard in and standard out. In the FS module, we're reading and writing from files in HTTP and this TCP socket. We are reading and writing to our network card. And Zlib and Crypto, we're just working with some data. In some cases, it could be a file or just something in memory. and child processes and these process.standard error standard out. Here we are talking to different processes. So you understand the concept using the FS module, you are understanding how to use streams in all the other modules. Now, first you could see the list of events that we have available on this stream.writable. Now, they are pretty self-explanatory. If you just read them, you'll understand what they do. Here it says this close event is emitted when the stream and any of its underlying resources, a file descriptor, for example, have been closed. So if let me just jump back into my code editor. So if we try to close this file handle, this stream is going to emit an event. So I'm just going to write it pretty quick. So stream.on close. And I'm just going to say stream was closed. And let's just also comment all these code out. You don't have to do this, I want to just demonstrate how this event works. So if I just close that file handle, so file handle.close, now the stream will emit this event, and we're going to get into this point. So let's run it pretty quick. So node write many, and sure enough, we get stream was closed. I want to back up. Okay. So you could just come here and read these different events, and they're really, really easy to understand. At least most of them. I got lost. Where were we? All right, here. So yeah, this is the close event. And also I just want to say, always read the description of these events and methods and properties before you use them, because it's really hard to memorize them. And in fact, you don't really have to memorize them because there's so much. Just come to these documentations and read them, and then you'll understand what they do. So you could sometimes find some interesting stuff here in the descriptions. Now here we talked about the train events, and this is the example that we wrote, writing 1 million times to something. Now in this case, it's not specifying the writer. The writer could be a stream that's off of a file, or it could be a response object or a request object or any other thing really. So let's see what else we have. We have the error event. Again, pretty self-explanatory. Just read it and you'll understand what they do. We have the finish event. We talked about it. This event will be emitted after we call the stream.end function. And also, all the data has been flushed to the underlying system. In our example, it means that it wrote to the file itself rather than keeping the data in memory. We also have pipe. Now we're going to talk about pipe and unpipe after we talk about the readable streams, so let's move on. Then we have cork. Now this is, if you run this, it's going to buffer all the data in memory, and it's not going to clear anything or do any final write, meaning writing to those internal resources. So sometimes it could be useful. Here we could see that the primary intent of this method is to accommodate a situation where we're writing very small chunks very rapidly, kind of like that for loop that we did previously. So you could make use of this one in some cases like these, but I don't know, I haven't really used cork, but if you want, go ahead, play around with it. It's not that hard to understand. It's actually super simple. When you write it, when you call this cork method, you're just not writing to that underlying resource anymore, and you're just buffering all the data in memory. And also you got to make sure to call the uncork function. Where is it? It's right here. Call this uncork method after you're done. We also have destroy, which again destroys the stream. And then you have some properties like writable.close. It's true if the close event has been emitted. So we can see that some of them are really easy to understand, and you need to actually come and read what these do whenever you want to work with streams. .end, we talked about it in great detail. Here it says calling stream.write after calling stream.end will raise an error, which is something that we saw. We also have a writable.set default encoding, which is really useful if you are just dealing with text, like a text file or an incoming request. But if you're dealing with other types of data that are not text, like an image, a video file, an application, anything that's not text, it's not really useful. Actually, it's not useful at all. I mean, you don't want to run this method on a stream that is dealing with an image file. If you do that, you're going to mess up your data. So only use this method if you are just dealing with text information. Then onQuark, which is just like that quirk, that quirks means that it keeps buffering all the data. If you call this method, it will just stop doing that and flush all the data to an underlying resource and do one write. Then we have another property, which is writable.writable, which is true if it's safe to call that write method. And that means that if the stream is not destroyed, errored, or ended. We also have an experimental property here, which is writable aborted, which is indicating it returns whether the stream was destroyed or errored before the finish event. Again, easy to understand. Writable ended, writable quirked, errored, finished, this high watermark value, length. Now this one could be quite interesting, writable need drain. And it's true if the stream's buffer is now full and the stream will now emit a drain event. So whenever we get to that point, this property will be true. And yeah, I guess this is pretty much it. And now here we're done with the writable section. And now we have to talk about the readable streams. So we're pretty much done with the writable streams. Now we're going to talk about the readable streams, and then we're also going to use these writable streams later in the video and also later in the course. This is a pretty important concept, and we're going to use this pretty much, I think, in every video from now on. We're going to have an example of streams, not in every single one of them, but definitely it's going to be highly used from now on in the course. Alright, let's now talk about readable streams. So in a readable stream, we read possibly from a huge file and we get the data in chunks. So in a writable stream, we write, and in a readable stream, we read. Alright, so let's see an example. Let me first clean up here. So I'm going to close this write many file, and I'm going to move all these files to a new folder. So I'm going to create a new folder and call it write-many. And I don't know if you guys have this des.txt file or not. I guess I was just experimenting. So I'm going to delete it, and I'm going to move my test.txt file and also my write-many.js file to this write-many folder. And now I'm going to create a new file, and actually a new folder, and I'm going to call it read-big, meaning that here now we're going to read from a file. So I'm going to create a new file, call it readbig.js. And what we're going to do is to read a file that we created using this write-many code. So we're going to create some huge files using this code, and then we're going to start to read them here in this file. So I want to first include the fs module, so const fs equals require node fs/promises. And I want to create one of these immediately invoked functions. And here I'm going to first create my file handle object, so file handle read, to indicate that we're going to read from this file. So wait fs.open. Now let's copy this file and paste it here in this readbig folder as well. So I'm going to paste it, and let's open this file first. So test.txt. The flag should be R because we are reading and we're not writing or appending or anything, we're just reading. And let's now create our stream. So const stream equals file handle read dot create read stream. Alright, so now this is a readable stream as opposed to a writable stream that we had before. So the way that we can consume data that will come to the stream is by adding an event listener on this stream, and the event is called data. And once the event happens, we're going to execute a callback function, and the first parameter, the only parameter that this function has, is a chunk. So we're going to get the data in this chunk. So let's just try to log it and see if we are getting these chunks. So console.log chunk. I keep doing this. I need a semicolon here so that my prettier works well. And now I'm going to open up my terminal, navigate to this readbeg folder, and I'm going to run the application. It's chunk and not chunks. And as you can see here, we are getting different logs. So we're getting the data of this file in different chunks. So I just add one more log and just say maybe add a divider like this and run it again. You're going to see that we're going to execute this function multiple times. So rather than getting the whole data, the whole 7.9 megabyte data in one chunk, which is going to occupy our whole memory, we're getting smaller, different chunks like this. Now, one thing that's different, if you log the length, it's not going to be that default 16 kilobytes. Rather, it's 65 kilobytes. So if you use this create read stream to create a readable stream of a file, the default high watermark value is going to be 65 kilobytes. So if you go to the Node.js documentation in the FS module, if I can find it here, file system, and if you just search for create read stream, which is here, if you take a look at the options, you could see that high watermark is defaulted to 64 kilobytes. So here it says, unlike the 16 kilobyte, which is the default for a stream.readable, this one uses a high watermark, which is 64 kilobytes. Now we could change this by specifying the high watermark value here. So high watermark, and whatever you specify here is going to be the size of your internal buffer. So if I just say maybe 400 bytes, and if I run the code again, so node readbeg, now you could see that my chunks are coming in length of 400 bytes. But I'm going to change it back to 64 times 1024, which is 64 kilobytes. Alright, so this is how a readable stream works. You just create your stream, and then you add the data event handler on that stream, and then you're going to get the data. Now, a readable stream could have 3 different states. When you first create your stream, you're not reading anything. As soon as you add this data event, what's going to happen is that the stream will start to read from that internal resource, and then you're going to get the data in chunks. If I remove this event, then what's going to happen is that the stream will be in a paused state and will no longer give me any data. And also I have one more event available on the stream, which is stream.onEnd. And if I call that, the callback function will be executed when we are done reading that source. Now let's try to read all the file and then write these chunks to another file. And let's see if we are getting the exact same file. So let's try to create another file here, and I'm going to call it dest.txt. And using a writable stream, I'm going to write these chunks to that destination. And I'm also going to change the name of this test to source to make it more clear what we're doing. So file handle read is going to be source.txt, and I'm going to create another one. So const file handle write equals await fs.open dest.txt, and the flag should be write because we are going to write. So the flag should be W. And I'm going to create my next stream. So I'm going to first name it to stream read, and I'm going to create the second stream and call it stream write. So file handle write dot create write stream, and now that we have our writable stream, I'm just going to write to it. So stream.write that chunk. So let's first see if we are getting the file. So our dest.txt file right now is empty. Our source starts from 0 and it goes up to 6 nines, and the file size should be, if I reveal it in my Finder, file size is 7.9 megabytes. So let's run this code, and I also need to use this here, and this should be stream write.write. All right. So if I run this code, well, it looks like it ran without an error, and if I take a look at my destination file, well, all is good. And let's also check the file sizes to make sure that we're not losing any chunks, and no, we're not, so both of them have the exact same size, as you can see here. But notice that this is not something that you should do. You shouldn't just write. Now, typically hard drives have a higher read speed comparing to a write speed. So here we're having some back pressuring. We're getting a huge amount of data, and we're not getting a chance to write them. So Node.js will keep buffering the data, just like we saw previously in our for loop, right? So our memory usage will be really high using this solution. So we need to use that drain event and pause and resume reading from the stream. Now, to demonstrate how much this pressure is, let's try to create a very big file using this write mini code and try to read that and do the same thing and benchmark our code. So I'm going to change this, and actually, you know what, I'm going to create a variable for this value because we keep changing it. So I'm going to say const number of writes, and right now it's 1 million, so 16 zeros, and I'm going to use this here and just say -1. So now here we're writing 1 million times, but let's change it to 10 million times to get a bigger file. So I'm going to run this. So node, I have to first go into that directory, and node write mini. It will take a while, possibly a couple of seconds. Yeah, it took 2 seconds, but now let me take a look and see how big the file is. The file is now 90 megabytes. So now let's try to do this again, but instead of using that small file, try to use this test.txt file, which is quite big. So I'm going to copy it, and I'm going to paste it, and I'm going to remove, I tried to open it, so now my computer is freezed because it's quite big. It's 90 megabytes, and if you try to open it, what is happening is that you're trying to move it all to your memory, and that's why it's going to be stuck. So I have to, well, I guess I had to open my code editor, so be careful not to open this test.txt file. So now I'm going to delete that source and change the name to source.txt. So now we have a quite big file here. Size is 90 megabytes. So let's try to do the same thing, but let's also take a look at our memory usage. So I'm going to open up my activity monitor and search for Node here, and let's run the code. So I'm going to navigate to that folder and run the application. Well, looks like that it was quite successful and was quite fast actually. Let's see if we are doing the copy correctly. So I'm going to reveal in Finder, and yep, we are. So the reason is actually we're not doing that many writes comparing to that for loop. That the for loop took a little while here to complete, and the reason is we're writing in very small chunks. Now each chunk is possibly just a couple of bytes, maybe 5 bytes, but here our chunks are very big, they're 64 kilobytes. So we're doing a very low amount of writes, but still we are having that memory pressure. If I try to create a very big file, so this is right now 10 million. Let's try to add in 2 more zeros to it. And what's the number right now? So it's a million, so it's 1 billion. So let's try to write 1 billion to that file and get a very big file, a gigantic file, and try to do this again. So I'm going to save, and I'm going to do that whole process again. And this is now going to take a while to complete. So I'm now going to fast forward this video. Alright, it's been a while. I have been waiting for like 2 minutes. So the CPU time of this process is now 2 minutes. And well, we're writing it so many times. So it's really going to take a couple minutes to complete. But the good thing is now you can really see the power of the streams. My memory usage is really consistent at only 50 megabytes. So it's pretty good and it's quite fast. I'm creating a huge file. I don't know how big the file will be, but if I go to my disk, so far the process has written 7 gigabytes of data to my disk. So the file is probably going to be like, I don't know, maybe 10 gigabytes or something around that number. So it's going to be quite huge, and we're writing 1 trillion times to a file. So you can see how powerful streams are, and nothing is really lagging. CPU is only at 100%. It's not, well, 100 is a lot, but I'm only using one of my cores, and everything in my computer is just working as expected. My computer is not slowed down, my memory usage hasn't jumped up to something really crazy, and everything is just working as expected. So let's wait more for this process to finish. Alright, so now we're done, and you can see that the code took 5 minutes to complete, which I know is a lot, but, well, we're running a billion times, so it's expected. It's definitely going to be huge. Now let's take a look at the file size. We're gonna really be careful not to click on it accidentally and try to open it. Now we can see that the file size is 10 gigabytes, which is a lot of data. Now let's try to move this file to this read big folder and try to do this process again, but using this file. So I'm going to change its name to maybe text gigantic. So a very huge file, and I'm going to delete the source